In this video, we're going to be looking at how we can add and subtract radical expressions. So we're going to take that concept that we learned previously about simplifying radicals and apply it to just combining radical expressions by addition or subtraction. So let's take a look at the first example. We have the square root of 3 plus 5 square roots of 3. So basically all this says, you can kind of treat these radicals like variables. So I kind of have x plus 5x. So that would be 6x, but in this case, square root of 3. And so our solution is simply that, 6 square roots of 3. Okay, let's look at example B. This one's a little bit more difficult. So this one we have this 2 times the square root of 6 plus the square root of 24. Now, we can't combine these because it's like having two different variables. If we have two different radicals, you can't combine them. But if we look at the square root of 24, we can simplify that. We can look that 4 goes into the square root of 24, so we can break that 24 down into the square root of 4 and the square root of 6. Now the square root of 4 we know is 2, so this really becomes 2 square root of 6, just bringing that down, plus the square root of 4, which is 2, and then bring down the square root of 6. So now we have 2 square roots of 6 plus 2 square roots of 6. So that makes a total of 4 square roots of 6. And that's our answer for that one. Let's take a look at letter C here. Now we have the 3 square roots of 2 plus the square root of 5 minus 4 square roots of 8. So first we want to do, can we simplify any of these radicals? 3 square root of 2, I can't do anything with that. I'll just bring it down. Square root of 5, can't do anything with that. I'll bring it down. Now this 4 square root of 8. The square root of 8 we can break into the square root of 4 and the square root of 2. So from there, we're going to bring down this minus 4, and then we're going to simplify square root of 4. That becomes 2, so it's 4 times 2 now. And the square root of 2 I can't simplify, so it'll just come down. Now simplify this one step further, we get 3 root 2 plus square root of 5. And we have negative 4 times 2, that's negative 8 square root of 2. I simplify this one step further, because if you look, I have 2 terms that have a square root of 2. So 3 minus 8, that's going to be negative 5 root 2 plus square root of 5. Because I can't combine that square root of 5 with anything, so I just brought it down. And that is our final answer. Kind of neat. Let's take a look at one more. Okay, this one. There's going to be a lot of simplifying in this one. Look at the square root of 40. That has a 4 in it, so square root of 4, and the square root of 10. And that 9 just comes on down. Okay, now let's look at that negative square root of 300. So bring down that negative. Now the square root of 300, we can break that into the square root of 100. So and the square root of 3. Okay, and then finally bring down that negative for the square root of 90. That we can break into the square root of 9 and the square root of 10. So then we're going to simplify further here. Bring down that 9. Square root of 4 is 2, so that's 9 times 2. Square root of 10, can't do anything with, so that's the square root of 10. Minus. Bring down the square root of 100, that is 10. Bring down the square root of 3, doesn't simplify. Now your minus. Bring down the square root of 9, that's 3. Square root of 10 does not simplify. Now we look and see, can I simplify this any further? Well, I have a 9 times 2 here, so that, let's change that 9 times 2 into an 18. And then, if you look at this, we have an 18 square root of 10 and a negative 3 square root of 10. We can combine those together to make 18 minus 3, or 15 square root of 10. And then we'll just subtract this piece that doesn't have anything to combine, 10 square root of 3. And there is our solution. So it takes that whole concept of simplifying radicals, and then we're combining like terms basically from there, once everything's simplified. Alright, a couple more examples here. So this one, square root of 72. We want to find a perfect square that goes into 72. We want the largest one. So the largest perfect square that goes into 72 is 36. So we'll do square root of 36 and the square root of 2. And then for this one, we'll bring down that -4, and then the square root of 18, largest perfect square that goes in 18, is 9, and that times 2 would give me the 18. So now we're going to simplify this stuff. Square root of 36, that is a 6, square root of 2 just comes down. Minus 4 comes down, square root of 3, or sorry, square root of 9 is 3, and then square root of 2 I can't do anything with. This 4 times 3 becomes 12. Then I have 6 square roots of 2 minus 12 square roots of 2. So 6 minus 12 is -6 root 2. And there's our solution there. One more example here. In this one, again, we're going to be simplifying all the radicals first. So square root of 20, that breaks down into the square root of 4 and the square root of 5. 2 square root of 6, I can't really simplify it all, so I'm just going to bring that down. And then square root of 80, you can find a perfect square that goes in to 80. So I think 16 and 5 makes 80. 16 is our perfect square. Alright, so let's simplify this. Square root of 4, that is 2. So error there. Square root of 5, can't do anything with. Plus 2 square root of 6 minus square root of 16, well that is 4. Square root of 5, can't do anything with. Now I have these square roots of 5 to combine. 2 minus 4 is -2 root 5 plus 2 root 6. Now my radicals are different, so I can't combine those. So that is the final answer. And that's basically all you have to do to be able to add radicals together. Here is the page you need to do for practice on this lesson. So take a look at those problems. And if you guys have any questions, feel free to reach out to your teacher and ask them. And we're there to help you guys out.